Hello class, today we will be talking about parametric equations. Parametric equations are a set of equations for both x and y, where x and y depend on another variable, and usually that variable is time. Let's look at a simple example. Suppose I have a bug crawling around and its position is being tracked. Now the thing that is important to note is we are tracking his position. So when we first start tracking his position, he's at, let's say, this point of the kitchen floor. And we put an axis on it and we label this coordinate 0, -1. And then when we see him again, he's at this position. And that's after 1 second. And then we look away and 2 seconds has passed, but at 3 seconds, he's at this position, the 9, 5 position. And then at 4 seconds, he's at the 12, 7 position, and vice versa. So he's going on a path, and if I was just looking at this, I would say, oh, this is a straight line. It can be represented by the equation using the slope and the y-intercept of these 2 points. And that would be accurate, but we're ignoring the fact that each of his x and y coordinate positions are based not off x. X is not based off y, and y is not based off x, but they're based off of this variable, a quantity that's changing. And the quantity that's changing is the quantity t. And so this is an example of a parametric equation where x can be found by determining an expression based off of t. So in this case, if I take a look at this, it looks like x can be found based off of t and y can be found based off of t. How is that possible? Well, let's take a look. If I base x off of what t is doing, then it looks like x can be the same equation as 3 times t. And if I base y off of what t is doing, and it looks like that y can be found by taking 2 times t and subtracting 1. So here we have a way of representing the bug's path by looking at the expressions for x, which is 3t, and the expression for y, which is 2t minus 1. And that tracks the position of the bug based off time, where y is not dependent on x and x is not dependent on y. They're both dependent on time t. Now some of you may be saying, this is the same thing as a line. Why do we need to even include t? We can come up with an expression for this line based off of its slope and its y-intercept. And we can, but if we do that, then we wouldn't have any way of determining how t affects the position of the bug. And so if we want to know where will the bug be after 12 seconds, if we use the equation of this line in y equals 2/3 x minus 1, which is the equation of this line, then we would have no way of determining where the bug would be after 10 seconds or predicting where the bug will be in 15 seconds. So it's important sometimes to bring in the time quantity or variable so that we can have a way of determining or tracking certain devices. Now, yes, the graph, the position that the bug is traveling looks like to be a straight line, but if we change the dynamics of the parametric equation just a slight bit, it may not move in a straight line. Let's see what happens when we change y from 2t minus 1 to a different equation. So now we've changed the y coordinate to 2t squared. So that means initially the bug is at the position 0, 0, but then it moves to 3, 1, but then it moves to 9, 9. And as you can see, based off this, the bug is moving at a different type of situation involving, it looks like a parabola. And of course, this parabola has its own equation as well. But the path of the bug is changed based off the y coordinate, which is based off of t and not x. X stays the same, but y changes. And so this is an example of a different set of parametric equations involving t. And there are some parametric equations that will end up in having the path look like a circle. And some parametric equations will have the path looking different ways, like a wavy path. Now, of course, these cannot be represented by functions because of they fail the vertical line test, but they can be represented by a set of parametric equations that will represent as time increases their position. And we're going to take a look at that in class. There are no notes on this topic because it's really not much of notes, it's just examples, but I encourage you to read pages 570 to 566 to page 572. So you can look at the various different examples and be ready for it when we do the work in class as well. For the video assessment, I suggest you know how to identify if an equation is parametric, i.e. if you can represent the x and y formula based off the variable t. And I suggest you be able to know how to calculate positions of parametric equations if they give you equations and they give you the values for t. Hope this helps. Bye-bye.